Here are the notes for section 4.8, which is the solving problems with trigonometry, so word problems. So, more right triangle problems. So it talks about angle of elevation. Is the angle through which the eye moves up from the horizontal. So here's your horizontal. So angle of elevation is this angle here, looking up. Angle of depression is if you are above something looking down at it. Now, the thing to be careful of and to pay attention to is if you are on top of something looking down, some angle of depression, that's actually the same angle that someone would have to look up to see you. So the angle of elevation to your object, or sorry, angle of depression to your object is the same as the angle of elevation from the object back to you, or vice versa. Which makes sometimes drawing your triangle a little bit easier. All right, so example 1, the angle of depression of a buoy from the top of the Barnegat Bay Lighthouse, 130 feet above the surface of the water, is 6 degrees. Find the distance x from the base of the lighthouse to the buoy. So we have our lighthouse is 130 feet tall. We have an angle of depression. So this angle is 6 degrees. And we want to find the horizontal distance here. Now the thing is, this is also 6 degrees. Because if I was at the buoy, I have to look up. So you need to pick one of our 3 trig functions, sine, cosine, tangent, because that's what the calculator has buttons for. So from this 6-degree angle, I have the opposite, I have the adjacent, so I have the tangent. So the tangent of 6 degrees is equal to the opposite over the adjacent. So I'm going to multiply both sides by x to get it out from underneath. So x tangent 6 degrees is equal to 130. Then I divide everybody by the tangent of 6. So x is equal to 130 divided by the tangent of 6. And now I'm going to go to my calculator. I'm not going to turn this into a decimal right away because then I have to carry around a bunch of decimal places. 130, actually I need to make sure I'm in degrees, divided by the tangent of 6. So 1, 2, 3, we'll call it 7 feet. So I'm about 1,237 feet from the base of the lighthouse out to the buoy. Okay, example 2, from the top of the 100-foot tall Old Hall Mountain observes a car moving towards the building. The angle of depression of the car changes from 22 to 46. How far does the car travel? So I'm actually going to draw 2 different triangles. Notice my angle of depression is the same as my angle of elevation. So here's 100. This is going to be 22 degrees. And then later on, this angle is 46 degrees, but this is still 100. So I'm going to find the 2 x's and just take the difference between them. So this one, the tangent of 22 degrees is equal to 100 over x, 1. Over here, the tangent of 46 degrees is equal to 100 over x, 2. So I'm going to do a bunch of math. So the x is going to come over, the tangent is going to come back. So x1, and over here, x2. So I did the same steps I did up here, where I multiplied both sides by x to get it out from underneath, and then divided the tangent across. But I just did it all at once. So the initial distance, 100 divided by the tangent of 22, this is 247.51 feet. 100 divided by the tangent of 46, this is 96.57 feet. So the difference, 247.51 minus 96.57. So the change in position, delta x, is about 150.94 feet. Now, if you want a more exact thing, you can actually just literally type the equations in. So 100 divided by tangent 22 minus 100 divided by tangent 46. So about the same number, but without having to track decimals, which this is probably the cleaner and more accurate way, but as long as you carry enough places, you will be okay. Okay, so example 3, we've got a large helium-filled penguin moored at the beginning of a parade route, awaiting the start of parade. 2 cables attached to the underside of the penguin make angles of 48 and 40 degrees with the ground, or in the same plane, blah, blah, blah. So 10 feet from each other, how high above the ground? So I'm finding height. So essentially what I've got is this scenario. That's 10. this angle, and this angle. So this one's going to be the more shallow angle. That's 40 degrees. It's farther away, so it has to be less. That's 48 degrees. And this is some unknown distance. I don't know how far out from underneath my things are tied, but I can still build some equations. So for this smaller triangle, the tangent of 48 degrees is equal to opposite over adjacent. For the bigger triangle, the one that goes all the way to the edge, tangent of 40 degrees is opposite. Now the bottom side here is 10 plus x, because it's that distance plus another 10. So how high above the ground is the penguin? So what I probably want to do is I want to find the height, but I probably have too many variables. I have two equations, so I can rearrange them so that they are equal to each other, and then I can work this out a little bit more cleanly, or end up setting them equal to each other. So for example, I'm going to h by itself, it's going to be easier. So that first equation is just going to become h equals x tangent 48. The second equation is going to be h equals 10 plus x tangent 40. Now the thing is, the penguin is the same height in both cases, which means these two equations are equal. I'm actually going to do some distributing. Plus x tan 40. So these two things have to be equal. So get all your x's on one side. So this guy needs to come over here. So x tan 48 minus x tan 40 equals 10 tan 40. So the next step is actually to factor the x out. So from the left, so you'd have this. Should have left myself some more room. What's actually happened next is this whole quantity divides to the right. So I'm going to have x equals 10 tan 40 over tan 48 minus tangent 40. Now be careful, I can type that all in my calculator at once. So parentheses 10 tangent 40 divided by parentheses tangent 48 minus tangent 40. So that's the x value. This distance is 30.90 some odd feet. Now this though is the height. Height is this number times the tangent of 48. So instead of trying to write this decimal down, this x value gets plugged in here. So I'm just going to multiply it by the tangent of 48. So 34.3 feet. So whatever this value is, goes in for that x. So h equals 34.3 feet. Ish. Okay, let's see here. Coast Guard patrol boat leaves Port Cleveland and averages 35 nautical miles per hour, traveling 2 hours on a course 53 degrees, and then 3 hours on a course of 143 degrees. What are the boat's bearings and distance from Port Cleveland? So let's see here. Distances, bearings are measured from the vertical. So essentially what happens is, so from north, so the boat comes up, that's 53 degrees, and then the boat comes back down. This distance is 143 degrees, and I want to know what this distance is and what the total angle there is. So let's see here. We can figure out how long these sides are because we know the speed and how fast they're going. So 35 knots for 2 hours, so this side length is 70, 35 times 2. Then 3 hours, so this side is 105. So let's see here. I need to figure out what that angle is. So let's see. So to figure out, I need to figure out what that total angle is here. Well, this makes a straight line, so that's 143. This little piece right there is 180 minus 43. Oops, 180 minus 143. So it's 37 in here. This piece is alternate interior to this guy, so it's 53, which means that chunk is a right angle there, which means I can use Pythagoras to find the distance. So d squared is equal to 70 squared plus 105 squared. So let's see here. That's going to be 4,900 plus 105 squared is 11025. So plus 4,900, take the square root. So distance is about 126.2 nautical miles. Would be my distance. And then to find the angle, I actually am going to find this value here and add that on to 53. So let's see here. So we'll use opposite over adjacent, so we'll use 105. So theta is the inverse tangent of 105 over 70. So the inverse tangent of 105 divided by 70 is 56.3 degrees, but that's rotating from this point here. So that I have to add another 53 on to measure from vertical. 109.3 degrees is their bearing. So 109.3 degrees is the distance from this north all the way to here, and they've traveled a distance. They are 126.2 nautical miles from port. All right, and last place trig stuff shows up is what's referred to as simple harmonic motion. So a point moving on a number line in simple harmonic motion, if its directed distance d from the origin is given by either of these two equations, where a and omega are real numbers and omega is more than 0. The motion has a frequency of omega over 2 pi, which is the number of oscillations per unit time. So simple harmonic motion just means that the object does that. It's like when you're swinging, you are undergoing simple harmonic motion. You go back and forth and back and forth and back and forth. A weight on a spring bouncing up and down is simple harmonic motion, up and down and up and down and up and down. All right, so example 5. So in example 5, in a mechanical linkage like the one shown below, a wheel with an 8 centimeter radius turns with an angular velocity of 8 pi radian per second. So this point, 8 pi t. What is the frequency of the piston in cycles per second? Well, find the frequency, we just take 2 pi, this value here, omega, over 2 pi. So 8 pi over 2 pi is 4. So 4 cycles per second. When I was talking, I was going to find the period, which would be 1/4, the reciprocal of this. 2 pi divided by b gives you the period. B over 2 pi gives you the frequency. What is the distance from the starting position? Exactly 3.45 seconds after starting. So we need to find the position at 0 and the position 3.45 seconds, and then just find the difference between the two. So the distance at 0 is, plug it into my equation, 8 cosine 8 pi times 0, which is 8. And the distance at 3.45 is 8 cosine 8 pi times 3.45, which is equal to, we're in radian, so I'll switch my calculator back to radian mode. Be careful doing this. 8 cosine quantity 8 pi times 3.45. So this is 2.47. So the difference is about 5.53, what's my units? Centimeters. The problem. Okay, oops, off the screen there a little bit. All right, example 6, mass oscillating up and down at the bottom of a spring, assuming perfect elasticity, no friction or air resistance, which means the thing will bounce forever, can be modeled as harmonic motion. If the weight is displaced a maximum of 5 centimeters, find the modeling equation if it takes 2 seconds to complete 1 cycle. So the period is 2 seconds, which means the frequency is the reciprocal, 1/2. The period is omega over 2 pi, so if that has to equal 2, omega is 4 pi. So let's see here. Doesn't actually matter which one we use. So because, here we'll start at it. So here's t equals 0. So displaced a maximum of 5, so it goes down to -5 up to +5. So it goes down, pull it down, it goes up, comes down, so on and so forth. So the amplitude is 5 cosine 4 pi t. Nope, I did that backwards. That should be 1/2, which means omega is just pi. So 5 cosine pi t. I keep confusing myself with the period and the frequency. Omega over 2 pi is equal to the frequency. So if I'd done it the other way, I should have done 2 pi over omega equals 2. So 2 pi equals 2 omega, so omega is 2. So be careful. And let's see what we got next. Oh, that is the end of the section.